Okay, so we're continuing with inverses, but we're looking at new functions today. So those same rules still apply. Step 1, switch your x and y. So y becomes x, and x becomes y. And then we just use inverse operations to undo. So what undoes, because we got to break this y free. It's trapped right now under this radical. So we have to get rid of the radical. What undoes a cubed root? Cubing, that's right. All right, so we would cube this side, and we would also cube this side. Okay, so when we cube this side, it just becomes x cubed. And what happens to the right side when we cube a cube root? They just cancel. So basically, we're freeing up what was under that cube root. Okay, so now we need to continue to solve for y, because solving for y is step 2. So to solve for y, what would I do first? Subtract 6. So now I have x cubed minus 6 equals 3y. And then what would I do? Divide everything by 3. So I could think of this as 1/3 x cubed minus 2. Or I could leave it x cubed divided by 3. Either way is just fine. So you could leave this x cubed divided by 3, or you could write it 1/3. Now, the last step is to rewrite using inverse notation. So it's not just y, it is y inverse. Yes, ma'am?
Is it going to get harder than this?
Not really. I mean, we add a new function Monday, but it's the same 3 steps.
Oh, okay.
Yes, ma'am?
Instead of doing like individually by 3, could I just put it all over 3? Or?
You certainly can. Yeah, you sure could. Okay, so what she was asking was this. Could I write it like this instead? X cubed minus 6 all divided by 3. Yes. Okay, now, let me show you something right here. This could have been written like this. Do y'all see that? And if we wrote it like this is in the form to figure out where the starting point for this cubed root is. You always have to factor out a coefficient to find the starting point. Do you guys see that the starting point would have been -2, 0? Okay, because the opposite of what's grouped with your x is your x at the starting point. What's added to the end, which is nothing, is your y. So if we go back to the original equation and put it in the form to find the starting point, to find that translation point, we'd have to factor out that 3. So this would have been 3 times x plus 2. And so it would be -2, 0. Now, let's come back down here to the inverse. Do you see that there's nothing being cubed with the x? So the x value at the starting point of this inverse is 0. And the y is -2. What do you notice about this starting point and this starting point? Yes. Does that make sense for inverses, that we would just switch the x and y?
Yes.
Yeah. And we're going to see that holds true on every single one of these. That the starting point, that translation point, for whatever equation we're given at the beginning, if we switched it, would be the translation point for the inverse. Yes, ma'am.
So when you do like the x cubed minus 6 and you do that like over 3, why wouldn't you like do like -6 divided by 3?
You can. Yeah, that's why I said it would be or. You could write it like this or like this. So you could leave it, let me erase all this, as an x cubed minus 6 divided by 3. You could write it x cubed over 3 minus 2, or you could write it 1/3 x cubed. Those all are equivalent.
Okay.
All of those work. All right, so the next one I'm starting with a cubic. So what should I end up with? A cubed root. Okay, so let's go through those same steps. Step 1, switch the x and y. Switch, switch. Step 2, solve for y. Okay? So, every time we have to look at what we have and decide what we need to do to solve for y. So in this problem, what has to move first? The 1. So we subtract 1 from both sides. So we go minus 1, minus 1. And we get x minus 1 equals negative 2 y cubed.
Can I use the restroom?
Sure. Leave the door cracked, please.
Did you divide negative 2?
And that is exactly what we do next. We're going to have to divide by negative 2. Okay. Yes.
So, because you said we aren't allowed to have negatives on the bottom.
We aren't, and I'm about to deal with that. Let's, instead of leaving this negative out in the bottom, let's throw it out in front.
Now make the 1 positive.
Okay? Now, I'm not going to distribute it, and you'll see why in just a second. Because this negative, we can think of as like times negative 1. A negative is just like multiplying by negative 1. So in just a second, we're about to take a cubed root. So when we have a negative, it's going to come outside of the root. So right now, I'm not distributing it. I'm just going to leave it in there on purpose. I'm going to leave it right here on purpose. Yes, sir?
I thought that the cube cancel out when you choose cube root.
I haven't done that yet. I haven't taken the cube root. So we're about to. So let's do that next. So since we cancel these out, they're gone. And let's take the cubed, what is that? The cubed root of both sides. So this cube and cubed root do cancel on this side. And we're just left with y. Now, when we take a cubed root of a negative, isn't a negative times a negative times a negative a negative? So the cubed root of a negative is negative. So if there's a negative inside a cubed root, when we take it, we need to pull it outside of the cubed root. That's how we simplify a cubed root. So anytime we have a negative cubed root, like if I gave you the cubed root of negative 4, well, 4 is not a perfect cube, so there's nothing I can do with the 4. But the negative, I could think of this as the cubed root of negative 1 times 4. So the negative we actually can pull out of a cubed root. And because we can, we should. So if we have a negative under here, we want to pull it out. That simplifies that radical. And we're done.
That's everything?
That's it for that problem. Oh, no, it's not. What about, I'm missing the inverse notation. So close to being done. Okay, so let's go back now and investigate. This translation point was 0, 1. 0, 1. What is this x value? 1.
Just kidding.
What is the y value added at the end? 0. Did they switch? Yes. Yes, sir.
So when you start with cube root, you take the cube first, and then cube you take last.
Well, you take it when it's time, and it depends. You have to isolate the cube or the cubed root first. Now in number 3, the cubed root was already isolated. That's why we immediately cubed both sides. But in number 4, the cube was not isolated. We had 2 things that had to move first before we could do it. Now number 5, how many things need to move? 1 thing needs to move. So that we can isolate that cubed root of number 4. Number 5, excuse me. All right, so let's do it. Let's start with number 5. So step 1 is always switch the X and Y,
Oh, yeah.
and then, come on. All right, it wants me to write in green, so I'll just do it. Oh, no, it's not writing at all.
Let's see it.
That's okay.
The mouse
I'm gonna.
is quite fidgety and shaking.
It is very fidgety today. I'm with you. Let's see if I plug it back in, if it'll respond better. Sometimes that works.
So funny.
It's still not working. Let's see if I use the mouse. There we go. Now it's working. Okay. Okay, so we're going to switch the X and Y. Okay, so now we need to isolate that radical. So we got to get it by itself before we can undo the cubed root. So what do I need to do to isolate it? Will told us a minute ago. He said subtract 2. So now we have x minus 2 equals the cubed root of, this doesn't look much like a y, y minus 7. Okay, now this one's a little different. When we cube it, we're really cubing everything on this side, and we're cubing everything on this side. Now, we don't actually want to cube this side because that would be a pain. Do you guys remember Pascal's where we did 1, 1, 1, 1, 2, 1, 1, 3, 3, 1? To cube this, we would have to go back to this. And we didn't like that. So let's not do it. Okay? We're going to leave it as x minus 2 cubed. The real reason, not because we don't like it, the real reason we leave it like this is because this leaves it in the form where we can graph it correctly. Over here, we're left with y minus 7. So what's our last step?
Add 7.
So we get x minus 2 cubed plus 7 equals the inverse. Love it. Okay, so our check step relates back to graphing, so we ask ourselves, what was the starting point of the cubed root? 7, 2. What is the starting point of the cubic? 2, 7. Did they switch?
Yes.
Okay, good.
Chris gets a 7. Because that was really confusing.
7 is confusing, and we'll get there in just a second. All right, I will. Yes.
I must have did something wrong because I got, her and I both got x cubed plus 5.
Okay, so when you cube both sides right here, if there's more than one thing, you've got to group it and write it as a cube. So that's what happened right here. This step, when you cubed both sides, if x is not alone, it gets grouped in its being cubed.
Well, can you just leave it like? Can you come see what I did? Or can I bring it to you?
Okay, if you wrote it,
We took the 7 and brought it over, and so when we added the 7 and the 2, we got 5.
Yeah.
but the 2 is inside being cubed. so you can't.
Well, why do you have to cube the 2? Why can't you just keep it on this side?
Because on this step right here, we cubed both sides.
Well, do you have to bring the 2 over?
Yes.
Oh.
Yep, you got to move the 2 first.
Okay.
Yep, you got to isolate the radical.
Okay, that makes sense.
So, like on this one, after we switch, yes, Cole?
When you switch it, why can't you just like cube it and make it like a negative 8 and x?
Okay, if we cube this, though, it's not x cubed minus 8. Remember, I just did the little 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So when we cube a binomial, it would be x cubed minus 2x plus the squared 2x minus 8. If I actually cube this, it would become x cubed minus 6x squared plus 6x minus 8. If you cube this, because x minus 2 cubed means x minus 2 times x minus 2 times x minus 2. And that gives you that. That's why. All right. So number 6 is actually, could be easier to you. We switch the x and y. And we solve for y. So we move the 4 over. And then we have to take the cubed root of everything on both sides. Everything over here. Everything over here. To where on the left side, those two things get grouped together under the radical. And on the right side, the cube and the cube root cancel and leave me y minus 3. Then we move the 3 over. Now these are under the radical, this is not. And that's our answer. Okay, now let's do our little check step. What is the starting point of the original equation? 3, 4. Let's look at our answer. What would the starting point of our inverse be? 4, 3.
Yes, I got it right.
Okay? And that is our check step, guys. That's why that would have caught us on number 5. If we did something wrong, we should catch it when we look at those starting points. They should be the inverse of one another also. Okay. Number 7. Number 7, is it a cubic? No. Is it a cubed root? No. What is it? It's a line. Guys, I need y'all to...
Yeah.
That's fine, but you're making it hard for other people to pay attention. So if y'all could pass each other notes, that'd be fine. Just don't keep other people learning.
We usually do
Alright.
this back in middle school.
I'm gonna write you a
Okay, so this one's a line.
letter.
This one's a line. So we do it like we did yesterday. This line has fractions in it. If you guys don't like fractions, you can always clear them. And if you want to clear them, I would clear them right here.
You just multiply by
Okay, I would multiply everything through by 3 because that is the denominator. And if you don't like fractions, clear it. Get rid of it. And when I multiply by 3, this gives me 1y plus 2.
What if you multiply by the reciprocal of 3 over 2? Oh, yeah, that'll keep it as a fraction, right?
Yeah.
It's not gonna do anything.
So to clear fractions, you multiply through by the common denominator. And since there's only one denominator, that is the common denominator. So fractions are gone. And then we can move the 2 over. And we're done. So that is the inverse of the original line. Okay. I would like you to try number 8 as it is written. Thank you. And I'm going to add a number 9. Okay, you try 8 and 9. Okay, so let's look at number 8. Number 8, we switch. All right, guys. You can finish your conversations in just a second. Let's all give those that want to learn an opportunity to hear. So we're going to switch the x and y. And then we have to solve for y. So this has a lot of stuff we have to undo. And there's an order we have to do it in. The first thing we have to do is move the 4. So when we move the 4, it becomes positive 4. The next thing we have to do is divide by 2. And just go ahead and leave it like this. Don't actually do the division, because if you leave it like this, it actually works out better for you when you're looking at the equation. And then we have y plus 5 cubed. Well, here to undo a cube, we would take the cubed root of both sides. All right, I'm going to slide this other equation down because I didn't give myself enough room. No, I'm not. Try again. Okay, so this is the cubed root of x plus 4 divided by 2 equals y plus 5. And the last step is to move the 5 over. So if we leave it in this form, it's really easy to see the translation point. The translation of our answer versus what we started with. So if we look back at this one, the translation point of our original equation was -5, -4. Look at our inverse. What is the x? -4. What is the y? -5. That's a check step for you. You ought to be able to see that they have just switched. All right, this last one, we switch the x and y, and we solve for y. So we subtract 1. We cube both sides. All right, so since I'm cubing everything over here, I have to cube everything over there. And we leave it grouped so we can see the x. The x at the translation point. So this becomes x minus 1 cubed, y minus 2, and then we add 2 to both sides. Now, let's do our check step. The translation point of our original cubic was 2, 1. What is the translation point of our, cubed root versus cubic? 1, 2. Okay. So yesterday we did lines. Today we did cubics and cubed roots. Monday, we'll add quadratics and square roots. So we'll add another function to it. Okay? If any of you guys have questions about any of your homework assignments, I did have a discussion with the math teachers as a department, and they made me aware that some of you guys, not all of you, most of you are doing great, but some of you aren't doing your homework in regular math class. Okay? So, I may need to start checking that assignment also. Okay? All right.